Today we're going to talk about solving logarithmic equations. And so I'm going to start off by giving you some steps. So step 1 is we want to isolate the logarithmic term. And so you want to keep in mind that if we're isolating the logarithmic term, this means that you must condense any logarithms into one single logarithm. Okay, so step 2 is that you want to write the equation in exponential form. And step 3 is you want to solve for the variable. Now let's work through some examples. And so example 1 is the natural log of x equals 8. And so we want to remember that the natural log has a unwritten base of e, and so now from here, this natural log of x is our logarithmic term, and it's one single logarithmic term, so we don't have to condense or anything. And so the next step is that we're going to convert this into exponential form. And when we convert that into exponential form, we get e to the 8th power equals x, which is really not a nice term. And so we are going to leave that there as our final answer. Example 2, we have log base 2 of 25 minus x equals 3. And so this whole thing right here is our logarithmic term. And it's only one of them, so we therefore do not have to condense anything. And so we can go from here and convert this into exponential form. And when you do that, you end up getting 2 cubed equals 25 minus x. And well, 2 cubed here is just 8. So we can rewrite that as saying 8 equals 25 minus x. And now we need to solve for x, so we're going to subtract 25 from each side. And when we do that, we get negative 17 equals negative x. Since we have a negative on each side, we can make them positive, and we get that x equals 17 as our final answer. Example 3. We have log of x plus 2 plus log of x minus 1 equals 1. And so if you notice here, we have 2 logarithmic terms and we need 1 logarithmic term. So we have 1 logarithmic term here and 1 logarithmic term here. So we need to condense this. And so we have addition in the middle, which tells us that we need to multiply our arguments inside of one single logarithm. And so when we do that, we're going to end up with the log of x plus 2 times x minus 1 equals 1. And now I'm going to use distributive property to multiply these together. And so that gives me log of x squared minus x plus 2x minus 2 equals 1. And then we can simplify that to be log of x squared plus x minus 2 equals 1. And so now we have one single logarithmic term right here. And so that's our isolated logarithmic term that we want to use. And from here, remember that logs with no base have an unwritten 10, and we want to convert this into exponential form. And so that gives us 10 to the first power equals x squared plus x minus 2. When you have a quadratic, to solve for x, you need to make your equation equal 0. So we're going to subtract this 10. And that gives us 0 equals x squared plus x minus 12. And now we need to factor this. So 0 equals, and when you factor, it's what multiplies to give you this c value and adds to give you this b value. And remember, there's an unwritten 1 in there. So we're going to end up with x plus 4 and x minus 3, because 4 times negative 3 is negative 12, and 4 minus 3 is positive 1. And so now to solve this, we're going to take each of these factors, so one factor here, another factor here, and we're going to set each of them equal to 0. So x plus 4 equals 0, and x minus 3 equals 0, and we'll solve for x. So we'll subtract 4 here, and then we'll add 3 over here. And that gives us x equals negative 4 and x equals positive 3. So now we have these answers, and we want to make sure that we double check them to see if they work. So what's important to remember is that the argument of the logarithm cannot be negative. And so we're going to take the negative 4 first. We're going to go back to our original logarithm up here, and we're going to substitute it in. So if I substitute a negative 4 in here, and a negative 4 in there, we want to see, do we get a positive or negative arguments? Well, both of those would give us negative arguments, which therefore means that negative 4 is not an answer that works. So we can say that x does not equal negative 4, and now we test 3. So we're going to go back up here and test if we put 3 in for x right there. Do we get negative arguments? We do not, which means this will work. And so x equals 3 would be our final answer. And our last example, if we have 2 log of x equals log of 2 plus log of 3x minus 4. So we have a 2 here in front of our logarithmic term, and then over here we have 2 logarithmic terms, so we need to condense all of this. And so when you have a number in front of a logarithm, like on the left here, you want to remember you can move that up to become the exponent of the argument. And then on the right, we have addition between these two, and so we're going to condense by multiplying our arguments here together. So that ends up giving us log of x squared equals log of 2 times 3x minus 4. And so now I'm going to use distributive property to multiply this 2 through the parentheses there. So we end up with log of x squared equals log of 6x minus 8. And so now if we have the log of some quantity is equal to the log of some quantity, these two quantities have to be equal in order for this to be true, so we can just set them equal to each other and say x squared equals 6x minus 8. And now remember from the last example that if you have a quadratic equation, you have to have it equal to 0 before you can solve. So I'm going to subtract the 6x and add the 8 to each side. And so that gives me x squared minus 6x plus 8 equals 0. And now I want to factor this quadratic. And so when I factor this quadratic, you need to figure out what multiplies to give you 8 and adds to give you negative 6. And so that is going to be 4 and 2, but to get to negative 6, they have to be negative 4 and negative 2. And so now remember, we want to set each of these factors equal to 0. So x minus 4 equals 0 and x minus 2 equals 0. And then solve each of them for x. And so you get x equals 4 and x equals 2. And now we're going to take each of them back to the original equation and see if they make any of our arguments negative. So let's start with 4. So if I go back to the original equation and I substitute a 4 in for x, you have the 4 there, which is positive. And then if we go to the right side, 3 times 4 is 12, and 12 minus 4 is 8, which is positive. So both of those work. So this is a potential answer. Now let's try 2. So if we come up here and we put 2 in for x, the 2 on the left is positive, so that's positive. And then on the right, if we do 3 times 2, that's 6, and 6 minus 4 is 2. So those are both positive, so this is also an answer. So in this case, you have 2 potential answers.